In 44 years of combat operations, no M1 Abrams has ever been destroyed by enemy fire. Not in the Gulf War, not in Iraq, not in any engagement where this tank faced a real opponent. A 68-ton machine, a $9 million target. Operating in some of the most hostile environments on Earth, never destroyed by the enemy. The official explanation is the armor. That's what the military says. That's what the news reports. That's what most people believe. But here's the problem with that explanation. The T-72 has armor too. The T-90 has armor. Every tank on Earth has armor. So why does the Abrams survive when others don't? The real answer has almost nothing to do with what's on the outside of this tank. It has everything to do with what's inside. And the engineering behind it is still classified in parts to this day. Here's why this matters right now. Russia has committed over 2,000 tanks to the Ukraine conflict. China is running the largest armored modernization program in its history. The debate over whether main battle tanks still dominate the modern battlefield, or whether drone technology has made them obsolete, is being decided in real time. And at the center of that debate is one machine. Because if you want to understand the future of armored warfare, you need to understand why this particular tank has survived everything thrown at it for 4 decades, $9 billion in development, 3 generations of combat, 0 losses to enemy fire. That's not luck, that's engineering. And today, we're going to break down exactly what that engineering is, starting with the problem that nearly killed the entire program before it began. It's 1972. The Cold War is at its peak. The U.S. Army's nightmare scenario, Soviet armored divisions, thousands of tanks, pouring through the Fulda Gap in West Germany. The American tank at the time, the M60, is built around a single doctrine. Enough steel on the outside stops anything. Simple, logical, and by 1972, completely obsolete. Because Soviet engineers had figured out that you don't need to penetrate steel, you can melt through it. The RPG-7, the AT-3 Sagger, the T-64's high-velocity rounds, all of them used shaped charge technology that turned armor thickness into a nearly irrelevant variable. In the 1973 Yom Kippur War, Israeli Centurion and M60 tanks were being destroyed by Egyptian infantry armed with shoulder-fired rockets. In 18 days of fighting, Israel lost over 800 armored vehicles. Modern armor was broken. The U.S. Army launched a program with requirements that were almost impossible. Defeat any Soviet tank in service, survive any anti-tank weapon in the Soviet arsenal, move faster than any opponent, and stay light enough to be transported by air. The team that solved this problem made 3 engineering decisions so radical that military analysts still debate them today. Let's start with the one everyone focuses on, and the reason it's actually the least important. Traditional armor philosophy is simple. More steel equals more protection. If 10 inches of steel stops a round, use 12. The problem is physics. Every additional inch of steel adds roughly 500 pounds per square meter of surface. The Abrams needed frontal protection equivalent to 20 inches of homogeneous steel. The math: a pure steel solution produces a tank that weighs over 200 tons before you've added an engine, crew, or gun. The engineers reached back to classified British research from the 1960s. A composite system developed at the British establishment in Chobham, Surrey. The principle wasn't to stop rounds with mass. It was to defeat them with geometry and material science. An Abrams composite armor package works in layers. From the outside in, a hard steel faceplate that begins deforming incoming rounds, a layer of depleted uranium mesh, ceramic tiles, a secondary steel layer, then a spall liner on the crew-facing side. Each layer does a specific job. The outer steel initiates deformation. The depleted uranium mesh, then 1.7 times denser than lead, collapses shaped charged jets before they can fully form. The ceramics scatter and absorb kinetic energy from penetrating rounds. The spall liner stops any fragments that make it through. If a steel plate is a wall, composite armor is a series of filters, each one designed to strip a different type of energy from an incoming round. The result is frontal protection equivalent to approximately 600 to 700 millimeters of rolled homogeneous steel, in a package that weighs a fraction of what pure steel would require. The T-90's main gun can penetrate approximately 550 millimeters of rolled homogeneous steel at combat range. The Abrams absorbs that round, full stop. But here's what the armor alone can't explain. The Abrams doesn't just survive hits, it almost never takes them. Because what happens before a round is fired is where the Abrams truly wins wars. And that starts with a computer that most people have never heard of. In 1980, the most advanced Soviet tank, the T-80, had a first-round hit probability of approximately 50% at 2,000 meters under real combat conditions. Dust, smoke, movement, stress, flip a coin. That was how likely a Soviet gunner was to destroy his target on the first shot. The M1 Abrams was designed from the beginning to make coin flips irrelevant. The Fire Control System, the FCS, is a network of sensors and computers that sits between the gunner and the gun. And what it does is remove human limitation from the act of killing a target. Here is what happens in the 6 seconds between spotting a target and firing on an Abrams. The gunner acquires the target through a thermal imaging site that detects heat signatures through smoke, dust, and complete darkness. Not dim conditions, complete darkness. A laser rangefinder returns the exact distance to the target, accurate to within 10 meters at ranges up to 5,000 meters. The ballistic computer processes that data alongside the Abrams' current speed, the target's speed tracked in real time by the passive sensors, crosswind velocity, ambient air temperature, ammunition type, barrel temperature, and barrel wear. All of it calculated in under 2 seconds. The gun, gyroscopically stabilized on 2 axes, automatically adjusts its elevation and traverse to account for the firing solution while the tank is still moving at combat speed. The gunner fires. First round hit probability on a moving target from a moving Abrams, over 90% at 2,000 meters. A T-90 crew needs to stop their vehicle to approach that level of accuracy against a stationary target. An Abrams can match it at 40 miles per hour against an enemy doing 30. This is the engineering insight that rewrites everything. The Abrams doesn't dominate because its armor is better. It dominates because it fires first, and it almost never misses. But take away the third system, the one that almost never gets covered, and neither the armor nor the gun matters at all. Here's the tactical reality the 1972 engineers understood before anyone else. The best armored, most accurate tank on Earth is worthless if it can't reach the fight, or if it can't move fast enough to deny the enemy a clear shot. Mobility is survival. When an Abrams can reposition faster than an enemy can track and fire, the enemy's weapon system becomes irrelevant. You can't hit a target that isn't where you aimed. The problem? Moving 68 tons fast. General Dynamics made a decision that conventional military engineers considered insane. They installed a jet engine in a tank. The AGT-1500 is a gas turbine, the same fundamental technology used in helicopter rotors and aircraft auxiliary power. It produces 1,500 horsepower. For context, the M60 it replaced ran a diesel producing 750 horsepower at roughly half the weight. The Abrams produces double the power in a significantly heavier vehicle. The result is a power-to-weight ratio of 22 horsepower per ton. Most modern performance sports cars generate 15 to 20 horsepower per ton. The M1 Abrams, all 68 tons, accelerates from 0 to 32 kilometers per hour in 7 seconds. governed top speed on road, 67 kilometers per hour. Ungoverned test conditions, close to 90. The turbine has additional tactical advantages no diesel can match. It starts reliably across a temperature range from -50 degrees Celsius to +60 degrees Celsius. It runs on virtually any hydrocarbon fuel, diesel, gasoline, jet fuel, even heating oil if necessary. The real cost is logistics. The AGT-1500 burns approximately 380 liters per 100 kilometers of operational movement. The Abrams requires sustained fuel supply lines to operate effectively, a deliberate trade-off that shaped the entire doctrine of how it's deployed. But in the Gulf War, Abrams tanks advanced into Iraqi defensive positions faster than Iraqi commanders could coordinate a response. Entire armored divisions were destroyed before establishing effective firing positions. The tank was simply moving too fast to target. Now put all three systems together, and we can finally answer the question of how the Abrams compares to the tank specifically designed to destroy it. The T-90 was developed after the Soviet Union analyzed the Abrams program in the late 1980s. It's lighter, faster to produce, and designed around a doctrine of numerical superiority. The Russian logic: if you can't build one unbeatable tank, build 100 capable ones. On paper, the comparison is competitive. The T-90's Contact 5 explosive reactive armor adds effective protection equivalent to several hundred millimeters of steel against shape-charge rounds. Its two A46M gun fires rounds capable of penetrating 600 millimeters of rolled homogeneous steel at combat range. It weighs 47 tons versus the Abrams' 68. Significantly more deployable. On paper. In practice, 6-7 Klinch. In pure speech, the systems gap is decisive. An Abrams can detect and engage a T-90 at 2,500 meters. A T-90 needs to close to approximately 1,500 to 1,800 meters to have a realistic penetration chance against Abrams' frontal composite armor. That 700-meter gap is not a tactical advantage. It's a kill zone. The Abrams fires at 2,500 meters. The T-90 is still maneuvering into range. And if the T-90 does make it to engagement distance and fires, 70% first-round hit probability versus the Abrams' 90% means the Abrams shoots first, hits first, and the composite armor absorbs what comes back. It is not a fair fight. So why has the M1 Abrams never been destroyed by enemy fire in 44 years of combat? It's not one system, it's three engineering solutions, each one designed to solve a different dimension of the same problem, operating simultaneously as a single integrated machine. The composite armor makes it hard to kill. The fire control system makes it kill first. The turbine engine makes it impossible to catch. Remove any one of those systems and you have a competitive tank. Keep all three and you have something that has redefined what main battle armor can be for 4 consecutive decades. The engineers who started this program in 1972 were trying to answer one question. Is it possible to build a tank that dominates on every axis of armored combat at once? $9 billion, 3 wars, and 44 years without an enemy kill later. The answer is documented in the historical record. They figured it out. If you found the engineering behind the Abrams as impressive as I do, subscribe. We drop a new story every day. Tomorrow there's another one you won't want to miss.